Hello everyone, I welcome you all for SVK tutorials. So in this video I am going to discuss the solution for model question paper 1 which has been effected from 2022 which is for 21 batch for the 4th semester BE degree examination. The paper title is Mathematical Foundation for Computing Probability and Statistics, Computer Science and Allied Engineering branches with the subject code 21MATCS41. So my dear students, I will be solving the solution of this model question paper. Those who are not subscribed to my YouTube channel, do subscribe to my YouTube channel immediately. So I will be starting with module 2. So I will be solving in this video, I will be solving the solutions of module 2. In that, question number 3A, B, C I am going to solve. So let us move to the solution part. So consider the question number 3A. Let f and g be functions from R to R defined by function f of x as ax plus b and g of x as 1 minus x plus x square if g composition f of x is equal to 9x square minus 9x plus 3. Determine the value of a and b. So this is what the question they have been given. Let us write down what is given in the question. So the given function f of x is defined as ax plus b. I have note down that. And also they have provided g of x as 1 minus x plus x square. What is f of x? Ax plus b. And g of x is 1 minus x plus x square. What we need to find? We require to find the value of a and b. So provided the graph of the function x is equal to a 9x square minus 9x plus 3. For that reason, I have considered that definition. G composition of f of x is equal to 9x square minus 9x plus 3. We know that LHS is equal to RHS. So for that reason, I am noting down the right hand side part here. 9x square minus 9x plus 3 which is equal to G composition f of x can be written as G of f of x. I am writing the definition of composition function. That is what I am writing here. Then what is f of x defined? You can name this as equation 1 and you can name this as equation 2. So from 1 f of x is what? Ax plus b. In place of f of x, I am writing down as a what? Ax plus b. That becomes g of ax plus b. G of f of x becomes what? G of ax plus b. So next, what is g of x from equation 2? From equation 2, g of x is what? 1 minus x plus x square. You can think that this term is nothing but as same as x. Now we are substituting g of x. What is g of x? 1 minus x plus x square, right? So in place of x, what you are going to substitute? Ax plus b. In place of x, you are going to substitute ax plus b. That's all. You are going to substitute in place of x as ax plus b. That is what I am doing now. 1 minus ax plus b plus of ax plus b the whole square. Just expand this. What I am going to get? This is the expression I am going to get after expansion. It is, I have just multiplied by minus sign here. I got minus ax minus b and I have applied a plus b whole square expansion. It is nothing but a square x square plus 2abx plus b square. So simplify further means first I will write down the coefficient of x square term. First I am noting down that. Then I will collect the terms containing x. These two terms containing x. I will take out minus common. Since I have here minus here, that's why for that reason I will take out minus common. So I will be getting a. Since I am taking out minus common here, you are left out with a. Here my plus can be written as minus into minus. 1 minus I am pulling outside. So I am left out with another minus 2ab. That is what I have written here, a minus 2ab times of x plus of the constant term, that is 1 minus b plus b square. This is what I have written, constant term here. So now comparing the coefficients of left hand side and right hand side. So the coefficient of x square, is what? 9. The coefficient of x square here, a square. That's why 9 is equal to what? A square. The 9 is equal to a square. Next, compare the coefficient of x here. The coefficient of x is 9 minus 9, and here the coefficient of x is minus of a minus 2ab. So minus minus can be neglected. So we can write that as 9 equal to a minus 2ab, which is next. You are left out with constant term. The constant term is 3 equal to 1 minus b plus b square. That is what we have written. Then from solving the first equation, a square equal to 9, I am going to get a equal to plus or minus 3. I am going to get what? A value as plus or minus 3. As I have got a value as, I have got a equal to 3 and minus 3. I will be substituting this a equal to 3 once here, and also I will be substituting a equal to minus 3 once here. What we are going to get the values of b? Let us see now. If a equal to 3 in this expression, 9 equal to 3 minus 2 times of a value is 3b. So simplifying this, 9 minus 3 equal to minus 6b. So simplifying further, we are going to get the value of b as what? Minus 1. Since 6 by minus 6 will be minus 1. 6 by minus 6 is minus 1. So similarly, in case of if a equal to minus 3, if I substitute a equal to minus 3 in this expression, a value is minus 3. Here also a value is minus 3. Minus into minus plus becomes, so therefore it is plus 6. 3 2s are 6b. That is what I have written. So 2 into 3 becomes 6b, and I have shifted this minus 3 to left hand side. That becomes 9 plus 3 equal to 6b. Further, 6b will be equal to 9 plus 3 is what? 12. So 12 by 6 equal to what? 2. That is the value of b. So therefore I can conclude that the value of a and b as, if a equal to 3, the value of b is minus 1. If a equal to minus 3, the value of b is 2, are the required values of a and b. This is the problem of solving relations and functions. This is one of the important problem and easy to solve of this problem. I think you have all understood. So if you have understood, kindly do subscribe to my YouTube channel. So moving on to question number 3b, let a equal to 1, 2, 3, 4, 6. The given set A is 1, 2, 3, 4, 6, and R be a relation on set A defined by A related to B, if and only if A is a multiple of B. They have given the relation as what? A is a multiple of B. A is a multiple of B. Write down the relation R. We need to write down the relation R first. Then write the relation matrix. Then draw its diagram. First, in the given question, go through the set. The given set is A equal to what? 1, 2, 3, 4, 6. From this set A, we need to write a relation such that A is a multiple of B. What is A is a multiple of B means? So which is nothing but it is simple. A should be equal to B times of some value n. B times of some value n. So for example, if I consider if I consider 6 as A and 3 as B, so 3 multiplied by what? 3 is multiplied by 2 here. So I can say that 6 is multiple of 3, which is nothing but 6 is a multiple of 3. We can say like that. So that is what? A is a multiple of B. 6 is what? 6 is a multiple of 3. So with multiply by some constant called 2 here. So also we can say that 6 is divided by 3. We need to look in this manner, or else we can need to see the value called A is divided by B. A is divided by B. We need to see the relation such that A is divided by B value. I am looking for that type of relation. So if I consider 1, 1, So that is possible. Definitely 1 is divisible by 1. 1 is divisible by 1. And similarly 2 is divisible by 1. So for that reason 2 is a multiple of 1. So 2 is divisible by 2 itself. So I can say that 2 is a multiple of 2. Similarly 3 is a multiple of 1. 3 is a multiple of 3. So 4 is a multiple of 1. 4 is a multiple of 2. And also we can say that 4 is divisible by 2. 4 is divisible by 2. 4 is divided by 2. 4 is divided by 2. 4 is divided by 4 itself. 6 is divided by 1. 6 is divided by 2. 6 is divided by 3. 6 divided by 6 itself. So this is what the relation. This carries marks, maybe 2 marks. It may, if they ask the problem for 6 marks, they may go with 2 plus 2 plus 2 like this. So next, moving on to matrix relation. So once we find the relation, we will find out matrix relation. How to find out matrix relation with for the relation R? So for rows, I will be writing the set, that is 1, 2, 3, 4, 6 is the set they have provided. Also, I will go with column also, set A, 1, 2, 3, 4, 6. So if there is a relation 1 to 1, so if there is a relation 1 to 1, 1 is related to 1, I will put value as 1. Otherwise, I will put 0. Here 1 is related to 1 I have. So for that reason I am putting 1. So I will next see is there is a relation 1 related to 2, means 1 comma 2 is there in the relation R? No. So for that reason I am putting 0. Similarly 1 3 is not there. Similarly 1 4 is not there. Similarly 1 6 is not there. For that reason I will put these values as 0. Next I will go with the second row. 2 is related to 1. I will see in the relation. Yes, definitely 2 is related to 1. That's why I will put 1. Next, 2 is related to 2. For that reason, I will put 1. Next, 2 3 is not there. 2 4 is not there. 2 6 is not there in the relation R. For that reason, I will put 0. Next, similarly, 3 1 is there. 3 1 is there. For that reason, I will put 1. 3 2 is not there. For that reason, 0 it is 0. 3 3 is there. For that it is 1. 3 4 is not there. 3 6 is not there. Therefore it is 0. 4 1 is there. 4 1 is there. 4 2 is there. 4 4 is there. For that reason I am putting 1 1 1. The rest of the values are 0. Similarly from 6 6 1 is there. 6 2 is there. 6 3 is there. 6 6 is there. Therefore I will put only for 6 4 as 0. The rest of the values are 1. This is what called as matrix relation. So this is how to write matrix relation. It is also called as 0-1 matrix. This is the representation of 0-1 matrix. Did you all got how to solve this? So if you have any doubts, you can put a comment. So I will clear your doubts. So moving on to diagram, using this matrix relation or whatever the relation are, from this we can write a diagram. So I will see that from matrix 1. So there is a relation. First I can write 1. Then I will write down 2. Just I am going with a set of vertex 1, 2, 3, 4, 6. 4, 6. This is what. So then I can write there is a 1-to-1 relation. For that reason, when there is a 1-to-1 relation, I need to write a loop. That is called diagram definition. So next, is there relation 1 to 2? No. From 1 there is no other relation. No need of directed graph for that. Next, from 2 there is a relation. So you can draw a line from 2 to 1 with a direction. So from 2 there is a 2 to 2 itself. Therefore put a loop for that. Put a loop. So next, 2 from 2 there is no other relation. So next, moving on to 3. From 3 there is a relation 3 to 1. So for that reason I will put a line from 3 to 1. So 3 to 3 is related. I will put loop. So that is what there we have. So from 4 we have a relation 4 to 1. So draw a line from 4 to 1. So 4 to 2 there is a relation. Draw a line from 4 to 2. Then 4 to 4 there is a relation. Draw a loop for that. Next, from 6 there is a relation to 1. Draw a line from 6 to 1. Draw a line from 6 to 1. Then 6 to 3 there is a relation. Draw a line 6 to 3. Then 6 to 6, 6 to 2 is also there is a relation. Draw a line. Then 6 to 6 there is a relation. Draw a 2. This is called digraph of a matrix or digraph of a matrix or given relation. So this is how to solve the problem of relation using the relation R. We can extract matrix R or digraph of the given R. So moving on to next problem. Prove that in every graph, it is of the problems on graph theory. So prove that in every graph the number of vertices of odd degree is even. Prove that in every graph, in each and every graph, the number of vertices, whatever the number of vertices of odd degree is always even. You need to prove that odd degree of vertex is always, you are going to have even number of degree. So if we consider, let G be a finite graph with n vertices. Let G be a finite graph with n vertices, and E, you are going to consider G as a finite graph. Okay. So with that, finite graph means it contains n vertices and E edges. So in that, I will be defining n vertices as x1, x2 up to xk be the vertices of even degree. Point to be noted, of even degree vertices in that set. So some of the vertex may be having odd degree. For that reason, y1, y2, ym be the vertices of odd degree. This is odd degree, my dear students. This is odd degree. I have considered both the combination, the vertex containing even degree and odd degree. Therefore, k plus m will be n vertices. I am going to have number of sum of these two vertices will be equal to n vertices, where n is the total number of vertices. We know that to prove this, we will use a property called handshaking property. Handshaking property. What is that handshaking property? Means if you consider two hands, so two hands shaking each other. So if you consider two hands shaking each other, you can consider this as vertex V1. See now, so this hand will be an edge here. This will be an edge E1 and this will be also called an edge E2. So when I consider vertex V1, so therefore two ends are joining together and making two edges here. Therefore the degree of this vertex is what? 2. The degree of vertex V1 will be equal to what? 2. That's all. You understood? This is what the handshaking property. Very simple manner you can think. Handshaking property means there is a chances of state and true handshaking property. They can ask this question also. So just so we can say that so degree of this vertex is 2. So like that, we have a standard property. Using that property, sum of I running from 1 to n, degrees of Vi is equal to 2 times of edges. So knowing this property, so how many vertex we have considered? I have considered degree of degree of each x1, x2 up to xk. For that reason, summation I equal to 1 to k d of xi plus summation j equal to 1 to m degree of yj, which is equal to what? 2 times of edges. So the degree of vertex Vi I have splitted as even degree and odd degree. I have taken sum of those two, which will be equal to 2 times of edges. Then I will retain the odd degree of vertex as it is here. Then summation j equal to this is j equal to 1 to m d of yj equal to 2 times of E minus summation I equal to 1 to k degree of di, degree of xi. Since xi is what? Even. Xi is defined as even degrees. Xi is defined as what? Even degrees. Even degree of vertices. Xi is defined as even degree of vertices. So knowing that even degree of vertices, xi, since xi is even, we can say that summation of degree of each vertices will be what? 2 plus 2 plus 2 plus 2 will be 2 times of n itself. if you consider n vertices or I vertices, so 2 times of that, it will be always even itself. It will be always even. So even value minus even value is what? Even itself. Therefore, the degree of odd degree means this is what the vertex containing odd. So I can say that it will be equal to even. Hence I have proved that if you consider the degree of yj is what? Even. I have proved the theorem as degree of yj is also even. Hence the theorem is proved. This is how we need to prove this theorem. I think you all understood all these three problems. If you all understood, kindly do subscribe to my YouTube channel and also share this video with your friends. I thank you all for watching this video. Thank you, my dear students.